live on a dynamic planet. Through the eons, ice ages have ebbed and flowed. Likewise, meteorites have impacted the planet, causing mass extinctions. And species have risen and fallen due to changes in resources and ecosystems. All these things have happened without the footprint of humans. When we're talking about sustainability, there are three main themes that we want you to understand in order for you to move on to your other classes in the Sustainable Practices Program course list. These themes are climate change, population, and biodiversity. Each one could have a class completely devoted to it. We're also going to talk about the human activities that are related to these three subjects. Really, sustainability fits into just about every aspect of our daily lives and business. But these are just a few outstanding areas where sustainable action could pay off great dividends. The foundation will be built in this introductory class, and then you'll be able to move on. Let's talk about climate change. It's no longer considered okay to just talk about global warming because climate change is so much more than that. You could talk about droughts, you could talk about more rains being floods, you could talk about diseases. All these could be related to changes on the planet, climate change. But the planet is warming, and we attribute most of the warming of the past 30 to 50 years with increases in greenhouse gases, particularly CO2. And greenhouse gases work by having the sun's energy come down to the planet, warm the planet, and then the planet tries to radiate that heat off. But greenhouse gases in the atmosphere, whether you're talking about carbon dioxide, water vapor, methane, and others, they trap that energy and re-radiate it in all directions, a lot of it back towards the surface, heating the surface. 600 million years ago, there was over 20 times as much CO2 in the atmosphere as there is today. So we would think that there would be changes in temperature as well. If you want to understand climate change more recently, you want to find long records, but of higher resolution. So you get to look at fewer years, but you get to see changes that are more dramatic and rapid. Ice cores are an excellent example of how you can do that, where you can have thousands of years of snow building up in really, really cold areas, such as Greenland, Antarctica, the Himalayas, whatnot. You can drill down through those layers, extracting ice as you go, take this ice back to laboratories where you can study it for chemistry and for gases trapped in bubbles in the ice. We can look at an example of an ice core data set. On the bottom, we can see temperature. In the middle, in pink, we can see CO2 changes. Above that in green, we see methane, CH4. On the left, it's 400,000 years ago. And on the right, it's the present. And you can see that temperature and CO2 move up and down together. And that's one of the reasons why we think that they're related. Let's look at a higher resolution version, where we're looking at 150,000 years ago to present. And you could see that near time zero, climate hasn't changed that much. That's human time. That's when we've been around and when we've been taking note. And societies have risen and fallen because of these climate changes. But look at how much the climate system is capable of changing. It's something to take note of. All right, human influences. Combustion of fossil fuels and burning of the rainforest. Combustion is when you take oxygen and uniting it with organic compounds and having that release energy and release CO2. And CO2 is that greenhouse gas that we're talking about. And here we can see that industry, whether you're burning petroleum or coal, releases all sorts of energy and that CO2. And CO2 has been rising for the past 150 years dramatically, and that's in this red line. And if you look very carefully, the blue line right behind the red line is temperature. They are moving together. Temperature is rising as we increase CO2. Most of the scientists that study climate recognize this fact. If we look at computer-generated models for the past 100 years and the future 100 years, you could see that CO2 is only going to rise from now on. So that makes us think temperature is going to do the exact same thing. So what does that mean? Temperature is going to rise. Yeah, that's going to cause thawing of ice caps, sea level rise. But there are also things called feedbacks. And this is when you have an input into a system, maybe a little bit of warming. And from that, we're going to get a dramatic result of more heating. An example is by heating the planet, we have more evaporation, which puts more vapor in the air. And water vapor is another greenhouse gas that's going to cause more heating. Additionally, we're going to melt solid ice soil, permafrost. And that permafrost, when it thaws, is going to release methane. That's a greenhouse gas that's going to warm the planet. Additionally, when we thaw the ice on the planet's surface, there's going to be less reflectivity of the Earth because snow and ice is so reflective. It's going to absorb more heat, causing more warming. So what are the fallouts of climate change? We could have droughts. We could have increased rainfall. That could cause floods. We could have increased hurricanes, increased intensity of hurricanes, severe weather, changing ecosystems, which would then change biodiversity, and we could have diseases. Population is the second topic that we want to discuss. Population of any species will grow if given the chance, meaning they have enough resources, and there isn't competition for those resources, and there isn't competition in the sense that there are predators out there trying to feed upon them. Humans aren't any different. If you look at before 1,000 years ago, human population never increased above 500 million people. But then look, from 1,000 years ago to the present, things have grown exponentially. Humans have just taken off in population. You can see a little blip right here where there was the Black Death that knocked out 30 to 60% of Europe. But then after that, explosion. Between 1987 and 1999, population grew by 1 billion people, from 5 billion to 6 billion. To look at this a different way, population doubled between 1960 and 2000. That's 40 years. That's pretty incredible. That's 3 billion people. Population is still growing, but we're expecting it to plateau, possibly around 9 billion people. That is a heck of a lot of people. Let's put this into perspective. What are the pros of having a higher population? More hands for labor, more minds for ingenuity, potential for economic growth, and there's less stress of aged people on the youth because there are more youth to take care of elder people. Then you have cons. What are the cons of a greater population? There are more mouths to feed. There's stress and rapid depletion on resources. There's a need for an efficient means of resource distribution around the planet so people can have a high quality of life. There's environmental degradation, and there are social justice issues like distribution of wealth. This brings up an important consideration. What is the carrying capacity of the planet? What number of people can this planet hold with a given quality of life? A way to think about this is, what quality of life do you want for yourself and for other people? And then, what can the Earth provide? Right now, if we want the quality of life that most Americans have, we need 6 planets of resources. What are some of the causes of population growth? Well, lack of education has been connected with population growth. Improved medical technology, improved agricultural technology, bringing fresh, potable water to people all around the planet, transportation, and the information age. Discussions about population growth are quite controversial because who'd want to be told how many children you can have? Let's move on to the third point to consider, biodiversity. Biodiversity is the number of species that live within an ecosystem, a region, or on planet Earth. What's the importance of biodiversity, this large number of species? Well, for starters, our pharmaceutical industry has been based upon this. Additionally, we need to have all sorts of nutrients in order to support our health and the health of other organisms around the planet. And we want to have resilient ecosystems. Biodiversity also makes us resistant to many natural hazards, such as storms, where here we have mangroves, and mangroves could protect us from storm surges so that we don't have coastal erosion. Additionally, there's genetics. We want to have genetic diversity so that in the future, if we need to have food of a certain trait, we have the archive. But what's happening today? There's always extinction. Extinction is part of evolution. 99% of the species that we think have existed on this planet are gone. And we could talk about extinctions being periods of mass die-out, like 65 million years ago when we had a meteorite hit the Gulf of Mexico and knock out the dinosaurs. That's the hypothesis. So how does that compare to today? 1,000 species have been recorded as dying out in the past 500 years. Not a huge amount. But there are studies reporting that we haven't noticed even a fraction of the species that have died out. In fact, right now, there's supposed to be 10 to 100 times the background rate of species extinction. We could be in a mass extinction. Why? because we're bringing about habitat destruction, we're hunting, we're polluting, we're bringing invasive species into new territories, and we have climate change. So if we want to think about sustainability, how do we meet our needs and also preserve biodiversity? Well, let's reduce our toxins, reduce our pollutants, watch our carbon footprint, educate the public, and have economic incentives for all of the above, and let's have strong infrastructure to support this change. Thanks a lot.